Hi guys, so the format of this is I am just going to go through every single question that you did for your homework this week. So that's section A in the paper 1 in the textbook. I'll be honest with you, I haven't looked through these before, so this might not be the slickest run through of these questions, but at least you'll get a genuine sort of view on how I work through questions like this as well. I recommend absolutely not watching through this video in its entirety. I think that would be really boring and a bit unnecessary. There'll be some questions which you felt totally fine with. If that's the case, skip through them. Just go to the questions that you were stuck on and weren't sure how to do. I will try and explain, obviously, how I'm finding my answers as I go along. If you watch the video and you're still not sure, let me know, get in touch, and I can go through it again with you. I definitely want you to feel happy with every single one of these questions so that you feel ready for your mocks. Right, so the first question is asking us to differentiate each of those functions. The first one is y equals x to the power of 4. Luckily, this is a nice straightforward one, which uses the first rule that we learnt together, which is that you multiply by the power and you reduce the power by 1. The next question is slightly more complicated, unsurprisingly. So now we want to differentiate 1 over x squared. Remember, for functions like this, I find it easier to rearrange it first so it's just x to one numerical power and then differentiate it like that, because then I can use the rule that I used in the first part. So 1 over x squared can be rewritten as x to the power of minus 2. And now I'll use the same rule as before. So dy over dx equals minus 2x. And I'm reducing this power by 1, so that makes it minus 3, and absolutely not minus 1. After you've done that, it's good practice to write it back as a fraction, because that's how it was given to you. And if I want to do that, that minus 2 is being multiplied by that, so that should end up on the top of the fraction. But the x, it's just the x, which is to the power of minus 3. So I will write that on the bottom of the fraction. So in the end, it looks like minus 2 over x to the power of 3. The next question was one of the questions that I told you you wouldn't be able to do yet. I'm still going to go through it because I think it's good practice, and it's a question that involves the product rule. So it'll be nice for you to see it. But what you haven't learned how to do yet is you haven't learned how to differentiate sine x. We're coming up to it, but you haven't done that yet. So for C, we've got y equals x times sine x. So that's two functions that you will know how to differentiate multiplied together. And that means we want to use the product rule. And remember, the product rule is u v dash plus v u dash. So I want to start off not by writing things straight into the formula, but identifying my u and my v and differentiating those to give me u dash and v dash. So my u will be x. If I differentiate that, I have, not x, that would be weird. I have 1, and then my v is going to be sine x, and this is a bit you don't know yet, but I'll tell you for now so you can understand what I'm doing. If I differentiate sine x, I get cos x. So now I'm ready to use that into this formula here. So it's u, which is x, v dash, which is cos x, plus v, which is sine x, and u dash, which is 1, so I won't bother to write multiplying by 1. So this is my final answer to that question. For D, I'll come back up to the top, so I've got a little bit of space. So for D, my y is e to the power of 4x. And for this, you can either, some people just memorize the rule for this one, but that rule comes from the chain rule, because what we have here is a function inside a function. So we have 4x kind of inside e to the power of x. So if we use the chain rule, because it's good practice, then remember what we do is we cover up our inside function and we differentiate that as if I'm saying the word blah. So I'm differentiating e to the power of blah. That would just give me e to the power of blah. And then I need to multiply it by blah differentiated. So 4x differentiated is 4. I need to make sure I write back in that blah, so that is still e to the power of 4x, but now it's multiplied by 4. And our final step is just to rewrite that a little bit nicer, so 4e to the power of 4x. Right, next question. This is slightly more an applications question, although I have to be honest, I don't know why anyone would do this in real life. But anyway, what it says is, a single piece of wire has been bent to form the perimeter of a square. I'm just going to highlight the bits I think are important. So I think it's important that it's a square, because that means every side is going to be the same length. It tells me the side length is 2 centimeters. And then it says the wire is straightened out and then bent again to form the arc of a circle, and that has a radius of 4 centimeters. The wire just forms the arc, not the radii. Okay, I'll just highlight not the radii. And then it asks us to calculate the angle in radians that the arc subtends at the center of the circle. That sounds like a lot, but if I draw it out, I think it'll be a bit easier. So first of all, we had a square like this, and each side length was 2 centimeters. And I'll be honest, for me, I feel like the only thing that's happening there is it's telling us that the wire is 8 centimeters long. Because that's, after that, it just says, right, it's straightened out and then it's used for something else. And the next bit it's used for, so that purple bit of wire there becomes an arc. And I'm going to draw in the radii in a different colour because it said that it's not including the radii with the wire, but the radii come in like this. And then what we're looking for is this angle here. And it says that's going to be in radians. So, my feeling now is I'm going to want to use the formula for the length of an arc in some way. And that formula, you can find it in your formula books. And remember, you can use your formula book in the exam, so don't worry or feel bad about using it. I haven't got a formula book with me right now, so I hope I get this right. So the formula for the length of an arc is 2 pi theta. But I really hope it says this in your formula book. I'm sure it does. That theta in this formula must be in radians, which is good because this exam question is asking you to find it in radians. So I'm now going to sort of fill in what I've got. I know the length of my arc must be 8 centimeters because that's the length of the wire. I knew that because the square had side lengths of 2. So the length of the arc is 8 centimeters. I have 2 pi and my theta there. And it wants us to calculate that theta. So that theta will be 8 over 2 pi. And I can cancel out that 2 with the 8. So then I've just got 4 over pi equals theta. Now, some of you might be thinking, is that a full answer? It's still got a fraction in it. Yes, absolutely. I'd call this an exact answer because if we divide through by pi, pi is an infinite decimal. It's an irrational number. So if I did divide through by that, I would also get some kind of infinite irrational decimal. and so I'd have to round it. Now, if this was a calculator paper, you know, maybe I'd do that and round it to 3 significant figures. But we don't have a calculator. There's no further I can go here, so I'm just going to leave my answer as 4 over pi. And I'll be honest with you, mathematicians tend to prefer exact answers anyway. So even in your calculator paper, if it's possible to leave it as an exact answer, I would do, because it's good mathematical practice, even if it's not. You know, if it's a calculator paper, they'll take both answers, but you guys are good mathematicians, so leave it as an exact answer if you can. Cool, next question. This is a nice question because it's practicing a few different things about functions that we've learned. So it gives us 2 functions, f of x equals 2x plus 1 and g of x equals 3x minus 2. And we're finding 2 compositions of functions and an inverse function. So let's start off with, oops, sorry guys, why do I always do that? Let's start off with part A. So that's asking for f composed with g of x. Now, I always prefer to rewrite this as f composed with g of x like that, because then I find it easier to see kind of like my inside function, which is put inside the other function. I feel like that form of the notation shows it a lot more clearly. So what this tells me is g of x is going to go inside f of x. And by that, I mean that I am going to replace the x in f of x with g of x. So f of x is 2x plus 1. But when I replace that x with 3x minus 2, then what I'll have is 2. I usually put brackets around that function to begin with. So 2 times 3x minus 2 plus 1. You could leave it there. I'm going to simplify it because it's good practice. So I'll multiply through by the 2. So we have 6x minus 4 plus 1. And then that is 6x minus 3. I am not going to have enough room to do all of these. Hang on a second. Can I make this smaller? Hopefully. Not really. Well, I'll just put that to one side and write a little bit smaller for the rest of it. There we go. So part B is the opposite way around. So now that should be fairly self-explanatory. So now I want to insert f of x inside of g of x instead. So that's going to be 3, but I replace the x with 2x plus 1. And then I write that the minus 2 on the end. And again, it's good practice to simplify that. So I'm going to multiply through by that 3. So we have 6x plus 3 minus 2. And that can simplify again to 6x plus 1. Right. The final question asks us to find f to the power of minus 1 of x. Now that is the inverse of f of x. Make sure you're really clear on your notation. People often get that mixed up with one of those transformations of a function like minus f of x or f of minus x, particularly when it comes to sort of like a graphical question. But this is not that. This is the inverse of f of x. And remember, the inverse of f of x is when I go backwards through the function. So I'm swapping x and y. So let me start off by just writing out f of x, but at this stage I'm going to replace that symbol of f of x with a y instead. So we've got y equals 2x plus 1. And the reason I do that is because of what I've just said. I just said f inverse of x is when I swap x and y so that I go backwards through the function. So now I'm going to rewrite my x over here and my y over here. After that, I just want to rearrange to find y. Now, I know what people do. They rush this and they say, I can see what the inverse of f of x is really quickly, and they just write it down in one step. That is when people make mistakes. They might do things like divide through by the 2 first and subtract the 1 afterwards. So chill, easy. It's a 3-mark question. That means you've got 3 minutes, actually slightly over 3 minutes, because it's 90 marks in 100 minutes. So, take your time with it. Don't rush it. Do a good job of it. So first thing I'm going to do is subtract that 1. So I have x minus 1 equals 2y. And then I'm going to divide through by the 2. So I have x minus 1 all over 2 equals y. Now, if I'm being very good, I should now rewrite that sort of with this notation. So my final answer is the inverse of f of x is x minus 1 over 2. Cool. Oh, okay, so our next question is a question about logarithms. And my feeling is this question is checking how well do you know the logarithm laws. So it tells us that log x equals p and log y equals q. And then the rest of the questions are kind of asking how can you make up those logarithms in the questions from log x and log y. So it's like a puzzle trying to be able to make those final ones from what you've got. So for the first one, log x, y, I can use the logarithm law that says that I can sort of split that out into an addition. So it's possible to write that as log x plus log y. And we already know from the introduction to the question that log x is equal to p and log y is equal to q. Right, next question is log of x squared over y. Now this comes in 2 parts. I think the first thing I would do was just split that out into a subtraction instead. So I have log of x squared minus log of y. But we're not done there yet because at the moment I've got a squared sort of on the inside of my logarithm, and so I can't replace anything in there with a p yet. But we also have the logarithm law that says we can take that power and we can sort of bring it to the front of the logarithm. So I can rewrite that again as 2 log of x minus log of y. And now I'm ready to use the p and q. So I've got 2p minus q. Fantastic. Next question, log of the square root of x. This one's kind of got 2 steps to it. Hopefully you now know really easily that the square root of something is like it being to the power of a half. And the reason we want to change it to a numerical power is because then we can do that sort of green step in the question before. So I'll rewrite that as log of x to the power of a half. Now I can bring that half to the front. So half log of x, which makes it a half p. And the final question, it's a nice question because it checks kind of the other parts of the notation as well. So we have log 100 y. Now, it makes sense to split this out. You might not be sure where it's going yet, but let's split it out into log of 100 plus log of y. We can already change that log of y to q. And then here's where I check whether you remember that when you write log with no base, that is the same as it being log base 10. So let me write that out so you can see it. So what this question is really saying is it's log base 10 of 100 with the plus q on the end. And the way I say that to myself is, to what power do I put 10 to get 100? So in essence, 10 to the power of something equals 100. What is that? The answer is 2. So our final answer will be 2 plus q. Right, next question. So this one says, find the equation of the straight line that goes through the point 4, 3 and is perpendicular to the line y equals 2x plus 11. Give the answer in the form y equals mx plus c. So I'm actually going to start slightly further through the question. I mean, I think the important bits of information there are we want the equation of a straight line in that form. We know it goes through this point here, and it's perpendicular to this line here. So perpendicular means it's at right angles. And the rule that we have learnt about perpendicular lines is that if two gradients are perpendicular to each other, then when I multiply them together, it gives me -1. And the other way I've talked about that is we take the negative reciprocal. And what I mean by that is, for example, if we know M1 and we want to find M2, our perpendicular gradient, then with this formula here, I'd rewrite that as M2 equals -1 over M1. And that's the negative reciprocal because it's negative, and it's a reciprocal because it's 1 divided by that original gradient. So for us, we want a perpendicular gradient to the line y equals 2x plus 11, and our gradient here is that number 2. So to find our perpendicular gradient, that's going to be -1 over 2 instead. So what we now know is our straight line is going to be y equals -1 over 2x plus c. But what we're missing at the moment is the c. That's where the point that it goes through comes in. So that point 4, 3, we are going to substitute into our equation of our straight line. So the 4 becomes our x and the 3 becomes our y. So when I rewrite that, I have 3 equals -1 over 2 times 4 plus c. First, I'm going to multiply through that by that -1/2. So -1/2 times 4 is -2 plus c. And then I'm trying to solve to find the c, so I'll add that 2 over to the other side. So I have 5 equals c. Don't leave it there, guys. It's a 5-mark question. It deserves you to write out the final answer. So my final answer is this equation here, but with our value of c substituted in. So y equals -1 over 2x plus 5. I am not kidding. You get a final mark for writing it out like that, so don't skip it. I will take off a mark in the mock exam. Number 6. A piece of wood is 290 centimetres long. It's going to be cut into 10 pieces, each of which is 2 centimetres longer than the piece cut off before it. All the wood will be used up. Find the length of the first piece and the length of the last piece. What you will find in all practice papers is that question 6 and question 7 are the questions that really start to get down into, some more complicated multi-step maths where it does not make it obvious what maths you need to use. And if we look back through these previous questions quickly, it's fairly obvious what maths we need. I'm definitely differentiating that question. It literally says derivatives. This one, I had to do a little bit of working, but it did tell me I had an arc of a circle and a radius, and I was trying to find the angles, so I pretty much knew which formula I needed to use. This one's got the notation to tell you which maths you're using. This one's obviously about logarithms, and this one's obviously about equations of straight lines. So all of the questions up till question 6 and 7 will always be questions where the maths you need to use is obvious. Once you hit 6 and 7, that's where you really have to start thinking for yourself. So what I like to do with these questions is before I start doing anything else, I try and work out which piece of maths or pieces of maths am I going to be using. So I think it's obvious when you start off, a piece of wood is cut into 290 centimetres. Sorry, a piece of wood is 290 centimetres long. That's not very much information. It's cut into 10 pieces. But when it starts to say each of which is 2 centimetres longer than the piece cut off before it, that is when I start to think about sequences, right? Because, and I'm going to start writing this in sequence notation because it'll be useful to us later, we've got our first piece of wood, and then we've got our next piece of wood, which is going to be 2 centimetres longer than it. And our, I don't know why I'm writing a Y. There we go. Our next piece of wood, which is 2 centimetres longer than that, and so on and so forth until I get up to the final piece of wood, U10, because it's going to be cut into 10 pieces. So now when I look at this, I can see it's a question about arithmetic sequences. I know it's arithmetic sequences because I'm adding on that 2 centimetres each time. I'm not multiplying it by 2 each time. Then I want to think about, what information do I have here? So I don't know how long the first piece is. I do know I'm adding on 2 each time, so that means my common difference is 2. I know that in total I'm going to have 10 pieces, so my n is sort of 10 by the end of it. And then the final thing I know is that all of the wood adds together, all 10 pieces add together to make 290 centimetres. So what I am going to take from that, if I'm adding them together, all of the pieces add together to make 290, is that S10 is equal to 290. And after that, once I've pulled all that together, actually the rest of it's not so bad because I can use the formulas in the formula booklet to help me sort of work through the rest of it. So the questions, part A is asking me to find U1 and part B is asking me to find U10. So if I look in the formula book, there are 2 formulas for arithmetic sequences for SN. The first is, am I going to remember this correctly? I hope so. N over 2 U1 plus UN. And the other one is N over 2 2U1 plus N minus 1 times D. There we go. So these are our choices. Now, looking at what I'm trying to find here, first of all, I'm just going to go through with a little tiny eraser, small one like that, and I'm going to replace my N with 10 because I'm trying to find S10 and not SN. So I'm going to rub out all of the N's. Here we go. And I'm going to replace that with this 10 instead. So S10 equals 10 over 2 U10, 10 over 2, 10 minus 1D. There we go. And so now I look at what do I know and what do I not know? Well, I know what S10 is equal to, right? I know that S10 is 290. So I'm actually going to erase through again and replace my S10s with 290. There we go. So I'm going to replace it with this, 290, 290. And this is the stage where I have to start thinking about which formula is going to be the best for me to use. Because this first formula here is missing 2 things. It's missing U1 and it's missing U10, which are the 2 things I'm trying to find. But it's not very useful to have one equation with 2 unknowns because I'm never going to be able to work them both out. So instead, I'm going to focus in on this equation here because, sorry, I haven't added in something extra there. and that is the d. So I also know d is equal to 2. My apologies. There we go. So I'm going to replace that d with this 2. There we go. Now what I'm about to say makes sense, which is that equation only has one unknown, which is u1. So that's going to be the one that I solve to find my u1 first, and then I can use the one that I've highlighted in yellow to find my u10. So if I work this through, I have 290 equals 10 divided by 2, which is 5. 2 times u1 plus 10 minus 1, which is 9, times 2, which is 18. Make sure you do only multiply that 2 by what's in this bracket. It's not multiplied by the entire thing. I have no idea why they always write the d at the end of that bracket, because normally what you'd want to do is write the d sort of at the beginning of the bracket instead, and then I think it'd be a lot more obvious. Right. I have a few different ways to solve this. I could multiply out that bracket, or I can divide through by the 5. I think I am going to multiply out the bracket. Might regret it. We'll see how it goes. So 290 equals 10u1 plus 18 times 5, which is 90. And then I'm going to subtract off that 90. Oh, good. Okay, yeah, this was an easier way of doing it. So if I subtract off the 90, I have 200 equals 10 u1, and then my u1 is equal to 20. So now I've got my u1, I've answered part A, and then I'm going to substitute that into the yellow function to find the answer to part A. So that was, the answer to part B. So 290 equals 10 over 2, 20 plus u10. 290 equals 5 times 20 plus u10. 290 equals 5 times 20, which is 100, plus 5 u10. 190 equals 5 u10. And if I divide 190 by 5, I am going to get 19 times 2, which is 38. So 38 equals u10. Just to be clear, there's actually quite a lot of ways you could have worked out that answer. You could have just used the u10 formula instead. You could have added on 2 9 times, although that would have taken a while. So there's a few different ways you can do that, but as long as you got to the answer 38 in the end, it doesn't really matter. Right, on we go to the final question, and I know this is one that people had a lot of trouble with. I think it's because integration is something, first of all, that we covered very recently, which means it hasn't had enough time to properly sort of solidify, and also this is a particularly tough integration question. So, when I am finding integration difficult, I start to think about differentiation instead, because I don't know about you guys, but I feel a lot more confident with differentiation than integration, and it's a nice way to be able to check my answer anyway. Also, if we read this question carefully, it gives us a bit of a hint about how this question should work out. So it says, find the integral. It's a definite integral, so it's between 0 and 4, of 1 over 2x plus 1 dx. And it says, giving the answer in the form natural log of k, where k is an integer. So that is our sort of hint about how we are going to integrate this, because we know it's going to look like natural log of k. But let's sort of double check what that's going to look like, because I think an instinct would be to say, okay, I know if I differentiate natural log of x, so if my y is natural log of x, then my dy over dx is equal to 1 over x. Hopefully that's a rule you know. If not, I'm pretty sure it's in the formula booklet. Go double check. So if I'm differentiating natural log of 2x plus 1, what's that going to equal? Well, it's going to be a chain rule question, right? Because we've got a function inside a function. So first of all, I differentiate natural log of blah, which gives me 1 over blah. So it's going to be 1 over 2x plus 1, looking promising, right? But then I need to multiply it by blah differentiated, and 2x plus 1 differentiated is 2. So at the moment, if I said, okay, so I integrate 1 over 2x plus 1 and I get natural log of 2x plus 1, that's not quite right because that's going to be 2 times too big. So what I'm going to need to do is sort of divide through by 2 to get rid of this factor of 2, which is making it 2 times too big. Because if I had, let me change colours so you can see it, if I had an extra half here in front, then I'd have an extra half here in front, and then that would be what would mean I could cancel out that 2's and get the derivative that I wanted. So what that means for us is when I am integrating between 0 and 4, 1 over 2x plus 1 dx, that is going to integrate to a half natural log of 2x plus 1. And this is a definite integral, so I don't need to write my plus c, but I do need square brackets around it and to put my upper bound and lower bound on the right-hand side of those square brackets. Remember, I have taught you this while I've been on distance learning, so I have not seen enough of your work in your books. Normally, I would be walking around harassing you, making sure that you are using correct integration notation. So please look carefully at what I'm writing here. It is so important. You will lose marks if you don't use the right notation for integration. So now what we need to do is actually work that through and get through to a final answer. Don't worry too much about trying to get it into this form right now. We'll leave that till slightly later. So the first thing I do is substitute in that value of 4 for x. So I have a half natural log of 2 times 4 plus 1. And then I'm going to subtract away substituting in 0 in there, so a half natural log of 2 times 0 plus 1. There we go. Let's carry on working it through now. So I've got a half natural log of 2 times 4, that's 8, plus 1 is 9, minus a half times natural log of 2 times 0, which is 0, plus 1, which is 1. We're getting closer. We're close to a final answer, but now is when we'll worry about the fact that the question said it wanted the solution in the form natural log of k. So we don't want those halves there. We want them in some way inside our function instead. And now is when we're going to use kind of the opposite of that green rule we're using all the way back in that logarithm question, because we can bring in these halves as a power instead. So I'm just going to rewrite it like that first. So I have natural log of 9 to the power of a half minus natural log of 1 to the power of a half. A half is the same, the power of a half is the same as square rooting. So I've got natural log of the square root of 9 minus natural log of the square root of 1. The square root of 9 is 3 minus the square root of 1, which is 1. And I'm still not finished yet because it's still not in one single logarithm. So now I can use the fact that I've got the subtraction there and bring it in together as a division instead. So natural log of 3 over 1. 3 divided by 1 is 3. So my final answer is natural log of 3. Perfect. Right, that is all of the questions worked through. Remember, if you've looked through any of those and you've listened to my description and you're not sure, that is completely fine. Get in touch, drop me a message, and I can either, just help with any little things if you just want to ask a small question, or if you want me to go through an entire question or the entire thing again with you, I am really happy to do that. I want to make sure that you're well prepared.